Hello and welcome to our video on the log transformation. Going back to the circle of transformations, if you had data that looked something like this, so it's going in a curve looking like this, you would fit it to the circle of transformations here, and you could use log y transformation, the log x transformation. You could use these two. When it's a fraction, it's called a reciprocal. But the topic of this video is on log transformations, so we're going to use one of the log transformations. Other log transformations are here and here in the circle of transformations. There are none on this quadrant here. The log transformation, remember our aim is to get this curved line to look more like a straight line so we can fit a least squares regression line to it. The log transformation is a compressing transformation for high values of x or y. Each data point is moved back closer to the y-axis to create a straight line of data. So I've got a visual of this here. Log x compresses the higher x values. So this is a slightly different graph to the one up here, but it's still a log graph. It would be this one here, so we would use log x for it. There's your original data, and we're going to take the higher values and push them back towards the y-axis so that we end up with a straight line. So the lower values stay pretty similar, they don't move too far. Higher values move quite far and we end up with a straight line we can use for regression. The log y transformation works in a similar manner but compresses the scale on the y-axis, so they're moved up and down vertically. Here's an example. The scatterplot opposite was constructed using this data. From the scatterplot, it is clear that the relationship is non-linear. Looks like it goes like this. Looking at the circle of transformations, it fits with this one here. So we could use log x or log y. Could use the reciprocals as well, but it's a video on the log transformation, so we're going to use log. It says here, question A, linearize the scatterplot by applying a log x transformation. So they've told you which one, you don't even have to choose. And fit a least squares regression line to the transformed data. So we'll need our CAS to enter this data in. Today we're going to use the statistics application and go along until you find a spare column. I'm going to use an X column I've used in the past, but if I go along, maybe I'll go back here. If I go to my X column and I delete that X heading, so I get nothing here, and then I rename it and call it X, it's going to come up with the same data that I had originally. So to delete that variable X, you'll need to go to Edit, Delete, and List Variable. That will delete whichever one you have selected here. So I'm going to delete X so I can put some new values in for X. You could just call it a different letter if you wanted to, but I'm going to stick with what it says in the question so I don't get confused. Delete List Variable. Delete selected list in memory, yes. And I'll do that for Y as well. If you wanted to delete all your variables all in one go, instead of going through them all one at a time, you could go to Edit, Clear All, and that will clear all your variables. So I will call my first one X and my second one Y. You might like to pause the video now so you can fill in your data variables or data points. Okay, now that we've got our data points entered, we need to first of all draw a scatter plot to make sure it looks like the one in the question. Click Set Graph, choose X for X and Y for Y, click Set, click this button to show the graph, and I've still got a funny line going here, so I'm going to click back up the top here, click Set Graph and untick Previous Regression. I'll try and graph that again, and it looks a lot better this time. So these data points should be like the data points here in the example, and they are. We can see definitely non-linear, so we will need to transform this data before we can find a regression line. The transformation we're going to use is a log x transformation. So your third column here we will call log x. Type it in, and we're going to use the calculate function again, and just type in here. You'll need your keyboard up, and we will use this log, or you could use this log as well, either is fine. Log x. If you had height or weight for your variables, you would just type whatever the name of the variable in letters is. Make sure you're typing using the ABC keyboard as well. I've accidentally pressed a Z there. Press EXE and it will calculate the log values of all the X values. If you were doing the log Y transformation, you would use log Y and change the Y values to log Y instead of X. Okay, back to looking at our scatter plot. There we go. Now we're going to change this to be log X versus Y. So in the set graph function, for the X values, we will now use log X, and we'll use Y for the Y. Click Set, click Graph, and it looks closer to linear. Now looking at my graph, I can see there's one point that looks a little bit out. So I'm going to go back and check my lists here. And this X numbers goes 10, 44, 132, 10, 44. So I can see I've made an error with my second data point. And the second one along was the one that looked wrong. So I can change that now to a 44. And that should change the log value. I didn't check if it did. Change it back. No. Okay, to change your log value, click EXE here again. So to change this log value, we need to click in the calculate button area and click enter there so that we get 1.6. To get our new graph up, we just need to click regraph, or you can just click in the middle of the graph and it will update your graph, and now it looks more like a linear plot. We can now go ahead and calculate our linear regression using calculate regression linear. Our X list is the log X, our Y list is Y. If you want to copy your formula, you can, or copy your residual. Click OK. Make sure you've got the right regression line selected, and you need to copy down the values of A and B. And I can see here question B says write down the correlation coefficient, so we'll write down R as well. And click OK when you've finished copying them down. The regression line will plot for you. And then you need to answer the question over here. So fit a least squares regression line, we've done that. Part B, write down the equation and the coefficient, correct to one significant figure. So our equation is y equals 20. The 2 is the one significant figure, and we need to put a placeholder in the ones column. Minus 5, that's our one significant figure. X, that's our equation. and the coefficient r equals negative 0.99 to one significant figure. This will round up to -1. Exactly, which is a perfect correlation. Thanks for watching the video.